Hello everyone, I am Bashar. You are watching the channel Techquest Learning Point, and I'm here with a new episode of the tutorial programming C# for beginners. Today I am going to start a ninth episode on the new topic classes and objects. And it's the ninth episode of this series of tutorial programming C# for beginners. It's a complete C# programming course which enables any learner to make their basic foundation on C# programming, where 8 number of episodes has already been discussed with lab in Visual Studio 2022 environment. In this episode, I will discuss on understanding classes and objects, creating classes, fields and methods, constructors of class, destructors of class, and static member of class, as well as I will show with example to make your concept more clear in Visual Studio 2022. Okay, let's start. Understanding classes and objects. In object-oriented programming, classes and objects are fundamental concepts that help organize code and data. So, classes and objects are used in the C# programming to organize code and data. Class is defined by members such as methods and variables. A class definition starts with the keyword class, followed by the class name and the class body, enclosed by a pair of curly braces. Objects are real-world entities, an instance of a class. Access the members of the class using an object. When you want to access the class members, simply use the dot operator after the object name. This operator links the name of an object with the name of a member. Class. A class is a blueprint or template for creating objects. It defines the characteristics or attributes and behaviors or methods that all objects of that class will share. Think of a class as a cookie cutter. You use the cutter to create many cookies, but each cookie is a unique instance with its own shape and properties. Object. An object is an instance of a class. It's concrete realization of the class that has its own set of attributes and methods. So each cookie you create using the cookie cutter is an object. It has the shape defined by the cutter, but it may have been different toppings, colors, sizes. Relationship between classes and objects. A class defines the general properties and behaviors, while objects are the specific instances with their own unique data. You can create multiple objects from a single class, just like you can use a cookie cutter to make many cookies. As our example, imagine you have a class called car. This class could define attributes like color, make, and model, as well as methods like start, stop, and drive. You could then create multiple objects of the car class, each with its own unique values for the attributes and methods. For example, you could have a red Toyota Camry object, blue Honda Civic objects. Benefits of using classes and objects. Code reusability. Classes allow you to reuse code by creating multiple objects from the same blueprint. Modularization. Classes help break down complex problems into similar, more manageable pieces. Data encapsulation. Objects encapsulate data and methods making it easier to protect data integrity and control access. Creating class. Let's discuss how to create a class in C Sharp. To create a class in C Sharp, three tasks are performed in fact. Number one, use class keyword. Number two, define members within curly braces. Number three, create objects using the new keyword. Use the class keyword. Start by using the class keyword followed by the name of the class. It's common practice to capitalize the first letter of class names. Here is the example. Class, my class. Curly braces start, curly braces end. In this example, the keyword class is always used to define a class, and my class is the name of this class. All the required class members, including variables or fields and methods, are defined within starting and closing curly braces. Define members within the curly braces. Enclose the classes members, fields, properties, methods, etc. within curly braces. Here is the example with members. In this class person, name and age are the fields that are used to store data, and introduce is the name of a method which display that data. Create objects using the new keyword. To create instances or objects of the class, use the new keyword followed by the class name and parenthesis. Person1 equal to new person. Here the person object is created by using the class person. Person1's member name is called here to assign a value Alice. Person1's member age is called here to assign a value 30. Output of this line will be, hello, my name is Alice and I am 30 years old. Let's explain the example. Person class. This class represents a person with two fields, name and age, and a method introduce. Person1 object. This creates an instance of the person class representing a specific person. Setting properties. The name and age properties are set for the person1 object. Calling method. The introduce method is called on the person1 object, which prints a greeting message to the console. Here are some key points. Access modifiers like public control visibility of class members. Constructors are special methods used to initialize objects when they are created. Classes can inherit from other classes, creating hierarchies. We should keep in mind when define and use classes. Choose meaningful class names that reflect their purpose. Organize class members logically or readaptability. Use appropriate access modifiers to control access to class members. Fields and methods. Now I am going to explain the fields and methods in C# classes along with an example. Fields represents data that an object holds, declared within a class using a data type and a name. Each instance or object of the class has its own values for the fields. Have a look in the example. Class car, field for car's make, field for car's model, Field for cars year. Methods. Define actions that an object can perform, declared within a class using a return type, a name, and parentheses. Can contain code to perform tasks, calculations, or interact with other objects. Have a look into the example class car. Key points. Access fields and methods of an object using the dot operator. Methods can be called on objects to execute their code. Methods can also take parameters to customize their behavior. Look into the example below using fields and methods. Constructors are special methods used to create and initialize objects. Properties provide a way to control access to fields and add logic for getting and setting values. Access modifiers like public, private, protected control visibility and accessibility of fields and methods. Constructors of class. Let's explain constructors in C# classes along with examples. What are constructors? Special methods in a class that are automatically invoked when an object of that class is created. Their primary purpose is to initialize the object's state, fields, and properties and ensure it's ready to be used. They share the same name as the class and don't have a return type. Types of constructors. Number 1. Default constructor. Has no parameters. If you don't define any constructor in C# automatically provides a default parameterless constructor. Parameterized constructor. Take parameters to allow for customization of objects. Used to provide initial values for fields when creating objects. Here are the examples with class person. Here the method public person is the destructor. Here the public person. Here the method person is the constructor. Look into the matter there. Class name person and method name person. That is class name and person name. Class name and method name must be same in order to create constructor. Look into the parameterized constructor. Here the method has the same name of class with parameter string name int age. Here are the creating objects using constructor, using default constructor. Person1 equal to new person. Using parameterized constructor. Person2 equal to new person. Parameter Alice, 30. Here are some key points. Constructors are essential for object initialization. You can have multiple constructors with different parameters to offer flexibility in object creation. Use constructors to ensure objects are always in a valid state. If you create a parameterized constructor, the default constructor is no longer implicitly provided. Destructors of class. Destructors finalizers in C#. Purpose: to perform cleanup tasks when an object is no longer needed and is about to be garbage collected. Declaration: defined using the symbol tilde symbol before the class name without any parameters or return type. Invoked automatically by the .NET framework's garbage collector, not directly by the programmer. Here are the example. Destructor demo. Class name and method name is the same here. Some key points. Destructors are primarily used for resource management such as releasing unmanaged resources, file handles, database connections, etc., closing open files or streams, handling external connections. They are not guaranteed to be called immediately when an object becomes eligible for garbage collection. Use them cautiously as they can impact the performance if observed. In most cases, use I disposable and the using statement for deterministic resource cleanup. Have a look into the example of uses. Destructor demo obj1 equal to new destructor demo. obj1 equal to nar. Make obj1 eligible for garbage collection. The garbage collector will eventually call the destructor, but timing is uncertain. Best practices. Prefer I disposable and using statement for deterministic cleanup. Use destructors only when absolutely necessary for unmanaged resources. Keep destructors simple and avoid lengthy operations. Be aware of potential performance implications of destructors. Destructors cannot be inherited or overloaded. They cannot take parameters or have a return type. Use them judiciously or avoid unexpected behavior or performance issue. Static member of class. Static members in C# classes belong to class itself rather than individual objects of the class, shared by or instances of the class, accessed using class name, not an object reference. Types of static members. Static fields, variables declared with the static keyword, shared a single value across all objects of the class, often used for constants or shared data. Class math utils, static double pi. Accessing the static field, double area equal to math utils dot pi multiplication radius. Static methods. Methods declared with the static keyword can be called without creating an object of the class, often used for utility functions or operations that don't require instance specific data. Class string helpers. Calling the static method string uppercase text equal to string helpers dot convert to uppercase to hello world. Static properties. Properties declared with the static keyword provide a way to get or set static values, often with additional logic. Class user manager. Here are some key points. Static members are initialized before any objects of the class are created. They cannot access non-static members directly unless through an object reference. They are often used for constants or shared values, utility functions, global state or configuration, singleton patterns, enforcing a single instance of a class. Use static members judiciously as overuse can reduce code flexibility and testability. Consider alternatives like dependency injection or service locator patterns for managing shared resources and functionality. Now I come back to Visual Studio. Let's demonstrate how to create a class and its members. In Visual Studio, there is a template for creating the class. Go to the template. This is the space where a class is defined within curly braces. Now I will write code for a class car and their fields make, model and year. Two methods: start engine and accelerate. These are the code for the class car. Now I want to write the code for the main method. Here my car is the name of the object and it's declared by using the type car, and the type car is defined in the class car, which specify the object my car's characteristics. In this line, the field's make is updated by Toyota and the model is assigned by Carmi and the year 2023. Here, start engine member is called and accelerate member is called by the parameter value 60. Let's run the program in order to check the output. Output is car, Toyota, model, Carmi, year 2020, engine started, accelerating to 60 Mbps. Let's create another object by using the class car. Here is the another object, my new car, which is created by using the class car. Okay, let's run. This is the value for the first object and this is the value for the second object, my new car. Value Toyota, model Lexus, year 2022, Engine started, accelerating to 70 mph. In this way, we can create the many objects as per requirement by using the same class card. There is no need to change the value or code in the class, but we can modify the output by using these fields: make, model, year, and the accelerated parameter value. This is the code for the class card. Here, the access modifiers internal control visibility of class members. That means from where members are allowed to call. Access modifiers in C# are keywords used to specify the accessibility level of the classes, interfaces, fields, methods, and properties. They control whether these types and their members can be accessed from other code. The main access modifiers include public, private, protected, internal. Public access modifier. Access is not restricted. The member can be accessed from anywhere. Private access modifier. Access is limited to the containing class or struct. Protected. Access is limited to the containing class and derived classes. Internal access modifier. Access is restricted to the current assembly. Here the start engine method display text with the values of make, model, year. Here the method accelerate display the text with the value of parameter speed. Now I want to demonstrate the constructor. Okay, let's create another template for the class person. This is the template for the class person, where I will write the code for the class person. Our class name is person and a method name is person. Another method with the same name, but it has two parameters: string name and int is. Now I will create an object by using this class person. So height is bold format. Here person1 object is created as well as a member's name and age is initialized by unknown and 0 respectively. Just I create the object person1. Let's run the program. Name unknown is 0. There is only the object person1. Person1 is created, but there is no method called person. Now I will create another object person2. Here I will create the object person2 with initialize the two values Alice and 30. In this regard, the second method, that means this method is called as I assign the parameter name and age, Alice and 30. Okay, let's run. Name Alice is 30. Okay, that's it for the class. I hope it will clear to all that how to define the class and create object and constructor.